Hello everyone, how are you? I hope you all doing great. Welcome to EDAys Multi Online Education. So welcome back everyone. I hope you all doing great. So before starting our session, that is real number. Let me introduce myself. I'm Uday Kiran. I'm your maths academic specialist. I'll introduce our features and tools you have. So you have chat option with you. You can interact with me through chat. The live tutors. So they have you have expert tutors are there in the live sessions. So you can ask and clarify your doubts in the session and turn on your camera and turn off your audio in the session. Okay, actually participate in the session and clarify your doubts after the session. So we have exam preparation materials are there. So you just revise all the topics, and there are recording session also there. Just revisit all the recording session and learn some subjective knowledge, and then you can ESC or any test in your main examination. Okay. So without wasting our time, so let's get start our session about the real number. The next concept would be uh, let's get started. So previously, the last session we discussed about uh, revisiting irrational number, and we completed exercise 1.3. Exercise 1.3. All right. Now our next job is to find. So the next topic would be revisiting irrational number and their decimal expansion. Rational number and their decimal expansion. So welcome back everyone. So revisiting rational number and their decimal expansion. Before that, I'll ask you. Uh, okay, I'll give you one question. Like I'll give you 5/2. Let's give you 5/2. Let's do 5/2. If I give you 5/2 like this, what you do? Once again, 5/2. What you do? Generally, you will do division, sir. We know the division process. So I do division 2 to the 4 and 1. You put point here 0. So 2 5s are 10. Finally, you get remainder is 0. Remainder is 0. Okay. So if after finite number of steps, if you get remainder 0, observe here what is the quotient you'll get? 2.5. So it just stopped at 5. So after 5, there is no number. So it is terminated here. So if you get remainder as 0, let's write it here. If you get remainder as 0, then we called as terminating decimal. This is what we learned in the previous grade, terminating number or terminating decimal. Terminating decimal. All right. If we couldn't get remainder as 0, let's take an example of remainder not equal to 0. Let's take an example of what we take. Okay, let's take example of 3/10. 3/10. Once again, 10 here. 3 3s are 9 and 1. Put point here 0. 3 3s are 9. 1.0. Again 9. So you'll get remainder 3. So obviously the 3 is the quotient. I mean, it is repeating like this. So you can put bar on 3. You can put bar on 3. And here remainder, it is not equal to 0. Why? Because 1 any other variable we are getting. So if you get remainder is not equal to 0, then obviously it is non-terminating decimal. Non-terminating decimal. Clear, guys, about the difference between terminating decimal and non-terminating decimal? If you get remainder 0, it is terminating. If you couldn't get remainder not equal to 0, so that is non-terminating decimal. All right. Yeah. So why? Because before we understand the topic of decimal expansion, you just need all this number, all this word. Why? Because here they mention non-terminating repeating. I'll explain you what is non-terminating and repeating. So you couldn't understand. So that's why the basics are important. If you get remainder 0, terminating, and if you couldn't get the remainder 0, it is non-terminating. Recurring is nothing but the word recurring is nothing but repeating. The recurring is the word is nothing but repeating. Let's understand that word also. This is 1, this is 2. Now repeating is nothing but recurring. Recurring is the word is nothing but, let's take an example. Okay, so here we got 3.33 bar, 3.33333, so on. All right, so on. So we simply put like 3.3 bar. If you put bar here, the 3 is repeating. So that is why we call as recurring. And while coming to non-recurring, non-recurring. Non-recurring is nothing but it is not repeating. So what are the example we have to take? Let's take 2.34697812 and 941767. You are getting numbers like this. There is no end. Okay, there is no end obviously. So you will getting the numbers like this. We can't put bar. Here 3 is repeating. That's why I put bar. If you do like this, there is no correlation. Every time you will get getting the new number after division that. After division that, you will get a new number. So that's why. So in that case, we call as non-recurring. It is not repeating. It is not repeating, but it is terminating. Okay, it is non-terminating. Clear? Non-terminating is nothing but it is remainder is not equal to 0. You are getting new number till infinite. Okay. I hope everyone understood all the difference. These 4 words are important. Okay. Now, when it comes to the decimal, okay, I just write it here. The decimal expansion of before starting our session, you need to strong at basics, real numbers. You need to strong in basics. What is the decimal expansion of real numbers? So in real numbers, we have 2 numbers. First one is rational. Second one is irrational. Irrational numbers. Okay. Irrational numbers. Now observe carefully. In rational number, so it is terminating. Once again, it is terminating decimal. But rational number have 2 conditions. First one is terminating decimal, and second one is non-terminating recurring. Okay, first I just write the examples, then decimal. Okay, for example, if you take 5 by 2 as an example, we got 0. Sorry, not 5 by 2. Let's take any other example. 36 by 100. 36 by 100, we can write 0.36. So it is terminated at 6. It just stop it here and you will get remainder 0. Now coming to non-terminating recurring. Non-terminating recurring comes under, recurring is nothing but repeating. Non-terminating recurring also comes under rational number. So these are the important concepts, guys. In schools also, you couldn't get this type of knowledge. So they explain like this. They give a statement like this. When it comes to non-terminating recurring, so obviously you will get a remainder is not equal to. They think they said orally, okay. But you need to understand the concept by taking examples. And rational numbers comes under terminating decimal and non-terminating recurring. And here non-terminating recurring is nothing but what is the decimal? Non-terminating is nothing but remainder is not equal to 0, and recurring is nothing but it is repeating like this. Let's take an example of 5.34 bar. 5.34 bar is nothing but 5.3434343434 like this. All right. So we can write in the form of rational numbers also. That's why I'm writing that. All right. Now when it's come to irrational number is also non-terminating. For example, previously we taken 10 by 3, right? 10 by 3, you'll get 3.3 bar. 3.3 bar. All right. And also non-terminating, non-recurring. It comes under irrational number. Non-terminating and non-recurring. Okay. Non-terminating, non-recurring is nothing but, for example, if you take previously the example I taken as, let's cite it here. Yeah, 3.4789672312987654. So it was repeating like this. So there is no end after doing the division, actual division, you will get the number like this. It is repeating like this. Clear, guys? So it is comes under non-terminating and non-recurring. It is not repeating. But you are getting some values. It is prolonging like that. I hope everyone understood the difference between rational number and irrational number. Yeah, there are a lot of sums are there. You need to understand these basics. That's why I'm explaining all these things. Okay, let's move on. So these all these things we already learned about. The rational numbers have either terminating decimal and expansion of non-terminating decimal. A rational number has either terminating decimal or non-terminating recurring decimal. So that is what we'll write it here, either terminating decimal and non-terminating recurring decimal. Okay. So while I reading the statement, you couldn't understand what is the terminating and what is the non-terminating recurring, all those things. That's why I explained with the examples to you. Okay. Obviously, you know that a rational number would be P by Q form. All right. So let's take an example here. Observe what kind of expansion it is. They give an example 0.375. 375, you can write it as, so here, let's write it here. Okay, revisiting the example decimal expansion. So what we need to conclude, the rational number have either, either, once again, I copied something else. So either terminating and non-terminating. Let's take an example here, the decimal expansion of rational number and the decimal expansion. So here, let's take an example, the first one, 0.375, right? They given 375. So 375 after point. So you have three decimals are there. So you just write like 375 by 1000 by removing the point. So it was in the P by Q form. P by Q form. So you called as, it is terminated at 5. You can write it as, so P by Q form and Q not equal to 0. It is obviously terminating decimal. Terminating decimal. And second one is we just convert into P by Q form. That's why it is a rational number. A rational number. I hope everyone understood. We call it as a rational number. Why? Because we convert into P by Q form. Let's move on to the next example, 0.104. By observing the question, you can confirm whether which form it is, 0.104. So there is no dotted structure here. So it is stopped at here. It just stopped at here. I mean, terminated at here. Stopped is nothing but it is terminated at here. So you can write in the form of 104 by 1000. So it is in the form of P by Q, where Q not equal to 0. Obviously, the same answer. Terminating here, terminating decimal and non sorry, it is a rational number. It is a rational number. I hope everyone understood. Yeah, let's move on. 0.875. So by seeing that, it just stopped at 5. It is stopped at 5. I mean, it is terminated at 5. So that's why. So it is, I'm sorry. So it is terminated as 5. So you can write it at 875 by 1000. Okay. So you can write in the power of 10 in the denominator. 10 cube, 10 cube, 10 power 4, 10 power 4 like this. Okay. Okay, fine. So observe the pattern here. Let's take an example of 0.375. If I given you 0.375, so we just generally write at 375 by 1000. All right. But before that, you can equate that 10 we can write it as 375 by 10 cube. Okay. 375 by 10 cube. Okay. If you cancel further, so how many steps does it take? If you want to cancel further, so 5 times 200, 5 sevens are 35, and 5 fives are 75 fives are, all right, 35 and 5. Okay. Now still, if you want to cancel further, you'll get, I mean, I'm canceling to least number, minimum value. 200 if you cancel with 5, so you'll get 40, and here also 15. Still, if you want to cancel further, 15 5 threes are, and 5 eights are, you'll get. Finally, you got the minimum ratio would be 3 by 8. 0.375. If you want to write in the form of P by Q, so you'll get 3 by 8. What if I give you the big number like 875 by 10,000? How much time does it take? So here we get 1, 2, 3, 4. After 4 steps, we got 3 by 8. But 875 by 10,000, how many steps does it take? How many steps does it take? So in that case, so there is one method is there. So there is one method is there. So you need to find by, observe carefully. So 375 by 10 cube. So you can write, one second. Okay. So 375, I'll tell you the process. 375, you can write in the prime factoration. That is 5 cube, 3 into 5 into 5 into 5. Okay. Or else do one thing. So here 10 cube is there and 3 is there in the numerator. So 10 cube, you can write it as, can I write like 2 into 5 whole cube? Can I write like this? All right, 3 also there. So you will get 3 into, here 2 cube into 5 cube. I just split like this. Denominator 5 cube is there. If you multiply with 5 cube, so you'll get 3 into 5 cube, you'll get 375. By 2 cube into 5 cube, you'll get obviously 1000. Okay, you just rewrite it like this. That is what the decimal expansion they are saying here. Let's understand the question. Okay, let's understand the concept in ease with ease. Yeah, let x be a rational number whose decimal expansion terminated. Okay, x can be expressed as p by q, where p, q and q co-prime, and the prime factorization of q we can write it as 2 power n into 5 power m, 2 power n into 5 power m. Okay, and nm are non-negative integers. So what is this, sir? We couldn't understand what you are saying. Okay, I'll give you one example. For example, let we take uh, okay, 2 by 30. 2 by 30. The question like, so it is a decimal expansion of rational number or not? Decimal expansion of rational number or not? Decimal expansion of rational number which is in the form of 2 power n to 5 power m. The denominator, observe the denominator here, 30. You can write the prime factors for 30. So prime factor for 30, 2 into 15 and 2 into 3 into 5, 3 into 5, 15 we can write like this. Not 30, once again. Okay, let's take, okay, I just take simple example. Let's take 20. All right. So you can write the factors for 20. 2 by 20. 2 by 20. Sorry, this is 20. So 2 into, for example, I'm saying I given this example 2 into 10 and here 2 into 5. Finally, what we got? 2 square into 5 power m. Observe carefully, we are expanding the denominator, that is 20. So what we'll get here? 2 into 2 square into 5 power 1. 5 power 1. The denominator is in the form of 2 power n into 5 power m, where n is equal to 2 and m is equal to 1 if you compare with that. If it is in the form of like this 2 power n to 5 power m, then we can conclude that, so it is the decimal expansion. We can conclude that the given question, it is in the form of 2 power n, so that is equal to the decimal expansion of rational number. All right, now observe the examples here, whether they are in 2 power into 5 power m form or not. Okay, I'll give you another example for your reference. Let's do it here. Let's take another example like the same example. So we need to convert in the form of 2 power n into 5 power m. Okay. Okay, I'll give you example of 3 by 30. 3 by 30. Here, write the 30 prime factors. 3 into 15, sorry, 3 into 10. 10 we can write as 2 into 5. Now, what is the decimal expansion you'll get? 2 power 1 into 5 power n to 3 power 1. So we are getting the 3 also another variable we added here. But what is the form? 2 power into 5 power m. So that's why we can conclude that it is not in the form of decimal expansion. The decimal expansion, the remainder is the denominator is in the not in the form of 2 power n into 5 power m. That's why it is not a rational number. Okay. I hope everyone understood how to write in decimal expansion. We'll solve more example, then you can understand better way. Okay. All right. Yeah, let's look at the example here. 3 by 8. 3 by 8 first. 8, the denominator, it is right in the prime factoration. You get 2 cube. All right. So 2 cube. Let's do it here. 3 by 8. How they convert into small number? 3 by 8 is a small fraction, right? So you will have to convert into big number. That is 375 by 1000. How can you convert that? First, 3 by 8, you can write like 3 by 2 cube. What is the form we have to generate? 2 power n into 5 power m. 2 already there, 2 cube already there. So if you multiply generally with 5 cube and 5 cube in the denominator and numerator, what we will get? Now it is in the form of 2 power n into 5 power m. All right. We have to generate that. The question is not in the form of 2 power n into 5 power m, but we have generated like this. Only 2 is there. There is no 5. That's why we are multiplying with 5 cube. Okay. And 5 cube and 5 cube. So here 3 into 5 cube. So that is 5 5 is 25. 25 is 125. 125 into 3. So you'll get 375. 375. So you'll get the 375. The smaller fraction to bigger fraction, you just convert like this. All right. Let's look into the another example. 13 by example 2. Only thing is you need to convert this format. Example, what is that? 13 by 125. 13 by 125. First we'll denominator. What is observe the denominator? What is the denominator? 125 is the denominator. After writing in prime factoration, you'll get 5 cube. 5 into 5 into 5. Okay. In 2 power into 5 power m, already 5, the 5 term is already there. There is no 2 term. That's why you just generate the 2 term by. So you just multiply in denominator with 2 cube. With 2 cube. Now it is in the form of 2 power into 5 power m. Let's write it here. 13 into 2 cube is nothing but 8 by 5 into 2 whole cube. 5 into 2 whole cube. 13 into 8. So you'll get 104. 104 by 5 into 10 whole cube is nothing but 10 cube, that is 1000. So that is why you'll get 0.104. I hope everyone understood how to convert the denominator as 10. Denominator as in power of 10. Okay, let's solve the next example. 7 by 80. Whatever the number, guys, whatever the number, you just convert like this. 7 by 80 they given. Okay. 80 after writing in prime factors, I get 80 as, here they got 2 power 4 into 5 power 5. 2 power 4 into 5 power 1. So they get like this. Observe the denominator. Here 2 power 4. What we need to find? 2 power n into 5 power m. It is in the form of 5 power 1. But here there is not, the power is not in equal proportion. Here 2 power 4 is there. Here 5 power 1. Why not we convert it into 5 cube? Sorry, 5 power 4. So if you want to convert into 5 power 4, we just multiply with 5 cube and 5 cube. So you'll get 7 into 5 cube in the numerator by 2 power 4 into, now 5 power 1 into 5 cube. So you'll get 5 power 4. Now you'll get equal power in the denominator. 2 power 4 into 5 power 4. Okay. Initially, you'll get 2 power 4 into 5 power 1. So that is the condition we is not satisfied. Why? Because 1 here, 4 here. We should equate to 4 by, we just multiply with 5 cube, 5 cube. So you'll get like this. 7 into 5 cube. So you'll get 875. 875 by, so 10,000. That is 10,000. So you'll get 0.0875. I hope everyone understood. If there is no, if it is not equal the power, you just equate the power by multiplying with the particular value. Okay. All right. Yeah, the same value. You do the same way. Here 5 power 4 is only there. There is no 2 term. In the denominator 5 power 4, you can see only 5 power 4. That's why you just multiply numerator denominator with 2 power 4. So you'll get the equation like this. Okay. That is the one concept. Whether they given format like this, you can convert into in decimal fraction like this. If they given rational number, you just convert into decimal number like this. Okay, I'll give you one other example. Okay, let's do the exercise sum. One exercise sum, then you can understand. Okay, convert 17 by 8. 17 by 8. Read the question here. without actually performing long division. If, for example, I'll give you 17 by 8. What you generally do? So, sir, what you are asking, since childhood we are doing 8 by 17. 8 ones are 8. No, 8 twos are 16. So we'll get 1 here, put point 0. 8 ones are 8 and 2, put point 0. 2 twos, 8 twos are 16 again, 4, put point 0. So 2.125 you'll get by doing actual division method. Okay, 2.120. Why? Because here we got the remainder 0, we just stop it here. But when it comes to without actual division, they already mentioned without actual division method, state whether rational number will have terminating decimal or non-terminating repeating decimal. Let's do it here. 17 by 8. 8 we can write it as, first observe the denominator. Observe the denominator. What is the denominator? 8 is there. 17 by 8 we can write it as 2 into 2 into 2. So that is the nothing but 7 by 2 cube. 2 cube. Now what is the format for decimal expansion? 2 power n into 5 power m. Okay, here only two term is there. There is no 5 term. So that's why we have to equate by, we just multiply 5 cube and divide with the 5 cube. All right. So you'll get 2 into 5, 10, 10 whole cube, 7 into 5 cube, 5, 17 into 5 cube is nothing but 125. If you multiply 17 into 100, 1700, 25 into 17, so you'll get to 400. Okay, let's do it here. If you multiply after that, you'll get 17 to 125, you'll get 2125. 2125 by 1000. Okay, so after decimal, you just write like this, 2125 by 1000. You just convert into decimal fraction, you'll get 2.125. 2.125. I hope everyone understood. Clear, guys? So that is the exercise question we just now did, 7 by 18. Without doing actual division, I mean, this process we don't do. Okay, you can apply this process. You'll get the fraction, I mean, denominator is form of 2 cube. That's why you just multiply with 5 cube and 5 cube. Hope you everyone understood. Shall we do this first exercise, exercise 1.4? Then we'll move on to the next concept. All right. Because there is another concept is there. So first we'll do this concept. Why? Because if you do that parallelly, we learn concept, and if you do that this sums, then you can understand better way. Okay, let's do a few sums. Already we did the exercise 1.1. Let's make it as exercise 1.1. Sorry, not 1.1. So this is exercise 1.4. Exercise 1.4. Okay. In exercise 1.4, which question is 1 and second? First one, second one, 17 by 8. Okay. Okay, let's do the next question. Let's do the first one. First question. They given big number 13 by 3125. 13 by 3125. 3125. Okay. First write the prime factors for 3125. First write the prime factors for 3125. 1 second, guys. Yeah, you just write the first factors for 3125. Let's write the prime factors for 3125. Okay. So here 5 into 5 times 6. 630. Okay, 630 is there, and you can do normal division. So you'll get 6 to 5. 6 to 5, 5 into 5 into 1 to 5. 1 to 5. Okay. Now 5 into 5 into 1 to 5. 525 is there. So you'll get 5 into 5 into 5 into 25. We can write it as 5 into 5. Okay. Finally, you will get how many 5s? 1, 2, 3, 4, 5. 5 cube you will get. Okay. So 13 by 5 cube you will get. But what is the form we have to write? So we have to convert in the form of 2 power n into 5 power m. It is not in the form of 2 power into 5 power m. So what is the lack here? What is lacking here? There is no two terms. Sorry, I just write 5 cube. This is 5 cube, guys. 5 power 5, not 5 cube. This is 5 power 5. Why? Because 5 5s are there. Yeah, 5 5s. I just write it here, 5 power 5. 5 power 5. Okay. Okay, we have to convert in the form of 2 power n to 5 power m for decimal expansion of rational number. So here 5 is there. There is no 2 term. That's why we just multiply with 2 power 5 by 2 power 5. Here power 5 is there. That's why I multiply 2 power 5. Now the number becomes 3 into 13 into 2 power 5 by 5 into 2 into the power is equal. That's why I'm writing 5 into 2 power whole power 5. Okay. 13 into 2 power 5. 13 into 2 power 5 is nothing but 32. 2 into 2 into 2 into 2 into 2. 13 into 32 by 10 power 5. 10 power 5. 10 power 5 is nothing but 13 into 32. So you will get, yeah, 13 into 32. So you'll get, let's multiply it here. 13 into 32. So you'll get 416. 416 by 10 power 5 is nothing but 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So you'll get 0.0416. Am I doing wrong? Okay, 1 0 added. 1, 2, 3, 4, 5. Okay, so we'll get the decimal expansion like this. Or else do one thing. So here it is not in the form of 2 power n into 5 power m format. Why? Because we have generated that. All right. So you have only 5 power 5 is there. Only you'll get 5 power 5. So that's why you can write it like here. What is the question they're asking? Following the rational number, state whether the following rational number is terminating decimal expansion or non-terminating repeating decimal expansion. It is terminating decimal expansion or not? Observe carefully. It is non-terminating decimal expansion. Non-terminating decimal expansion. Why? Because why I'm saying this? Observe carefully. Here we got only 5 power 5. There is no 2 power 5 is there. We generated here. So that's why it is non-terminating decimal expansion. I hope everyone understood the first question. Okay. So denominator has 5. 5 is the only factor. That is why it is non-terminating decimal expansion. Second question already we did, and the fourth one, 64 by 45. 64 by 455, right? 455. Again, the first step it would be, so you just write the prime factors for 455. So 455, 5 into 455 by 5. Let's do it here. 455 by 5. So you'll get 91. 91, you can write it as, if you divided with 7, no 7, right? 7. Okay, if you divided with 7, so you'll get 7 into 13. Okay, 7 and 13 both are prime factors. We just stop it here. Observe the denominator. What is the form? We have to expect 2 power n into 5 power m. But we got the only 5 is the only one factor is there. There is no 2 factor. That is why 5 is the only one factor. Only one factor. There is no 2. There is no factor of 2. That's why we can conclude that it is non-terminating decimal expansion. Okay, so which is not in the form of 2 power n into, why? Because it is not in the form of 2 power n into 5 power m. 2 power n into 5 power m. So you just mention this word in your exam, guys. So by doing all these things, so you'll get 64 by 455. That is 5 into 7 into 13. Okay, it is not in the form of 2 power into 5 power m. That's why it is a non-terminal decimal expansion. You just mention these steps in your exams. What I am marked here. You just write all the words in your real exam. Okay, let's do with the next sum. Okay, 15 by 1600. Fourth one, right? Yeah, fourth one. 15 by 1600. 14 by 1600. First write the prime factor for 1600. 1600. So we just write like, okay, let's try with 5 into 5 3s are 15 and 5 2s are 20. Okay, 320. Now 5 into 5 into 5 6 the 30 and 5 4 the 64. 64 you can write it as 2 into 32, and 32 you can write it as, okay, 32 is nothing but 2 into 16. Okay, again I'm writing all those things, 2 into 2 into, okay, 14 16 we can write it as 2 power 4. Okay, I'm writing directly. Why? Because I think the next expansion, I think you people already know. So that's why I'm writing 2 power 4. Okay, finally what we get? 5 square into 2 power, how many 2s are there? 6. All right, 5 into 2 power 6. Now observe carefully. So we got 15 by 1600. We can write it like 5 square into 2 power 6. 5 square into 2 power 6. See, since the denominator, so we just mention over there, since the denominator is in the form of 2 power n into 5 power m, 2 power n into 5 power m. It is in the form of 2 power into 5 power m, right? So that's why you just write it like, therefore 15 by 1600. So it is a terminating decimal. Terminating decimal. Okay. 15 by 1600 is a terminating. In the question, they asked like whether they are terminating decimal expansion or non-terminating repeating decimal expansion. Okay. So just mention over there. All right. The previous question we got non-terminating decimal expansion, but here we got terminating decimal expansion. At least one we got. All right. Okay. So let's try with that. Yeah, 29 by 343. Which one? Fifth one, right? 29 by. Ignore the numerator. We are not doing with anything about the numerator. So we are dealing with only denominator. Okay. Let's write the factor for 343. 343. So 7 times the 7 times 49. 7 times 49. All right, let's check 7 into 49. Okay, 343. 49 we can write as 7 into 7. So we got 7 cube. That's why I just write here 29 by 7 cube. Okay. Then the question is the rational number which is in the form of 2 power n to 5 power m. 2 power n into 5 power m. So it is not in the form of 2 power n. So 7 is the factor here. We couldn't get any 5 and 2 factor. That's why you just mention over there the denominator is not in the form of 2 power n into 5 power m. 2 power n into 5 power m. So that's why thus 29 by 343 is a non-terminating decimal expansion. Non-terminating decimal expansion. Okay. Yeah, let's move on. Okay. By seeing the question, the sixth one, I'm sorry. Sixth one, observe the question 23 by 2 cube and to 5 square. Observe the denominator. They already did the prime factorization. Okay, so they saved our time. So 2 square, the denominator is in the form of 2 power n into 5 power m. Observe carefully. So here the factor of 2 is there and 5 factor is there. So it is in the form of 2 power n 5 power m. So that's why, therefore, the question 23 by 2 cube into 5 square is a terminating decimal. Terminating decimal without doing actual calculation. So we can see the denominator. We can confirm that it is a terminating decimal. Okay, terminal decimal expansion. Okay, let's move on to the. Okay, you can see the same question here. Okay, 129 by seventh one, right? Seventh one, 129 by 2 square into 5 power 7 into 7 power 5. 7 power 5. Observe carefully, guys. Here, the denominator 2 power n into 5 power m form. But here, what is the other variable added here? 7 is the one factor is there. 7 is another factor is there. That's why, therefore, 169 by the question 2 square into 5 power 7 into 7 power 5 is no. Okay, so the denominator you just added here is not in the form of in the form of this one, okay. So it is 16 power is a 16 by this question is a non-terminating decimal. Non-terminating decimal. Okay. Why? Because 7 is the one of the factor already added here. That's why I'm saying that this is the terminating. Then again, you can do the remaining things, guys. I just do that 35 by 15, 35 by 15, and you can do the rest of the things. Same procedure. 35 by 50. First, you can do write the factors for 50, prime factors for 50. 50 you can write 2 into 2 5, and 2 into 5 35 by 50, or else 13 by 50. Sorry, 35 by 50. The question here is 35 by 50. Okay. Okay. Anyhow, ignore the numerator, but we are dealing with only denominator. 5 we can write 25 we can write as 2 into 5. So now we'll get 2 power n into 5 power 2 power 1 into 5 square. Okay. So the denominator 35 by 2 power 1 into 5 square we got. Okay. So therefore the denominator is in the form of 2 power n into 5 power m. That's why it is a terminating decimal. So therefore it is a terminating decimal. I hope everyone understood. Quite easy. Okay, let's do the last question. 77 by 210. 77 by 210. Okay, so which one is this one? 10th one. All right, 210. So let's write the 210. 210 you can write it like 730, sir. 37 into 2 into 15. By seeing the question, you can already identify it is not a decimal expansion. Why? Because it is not in the form of 3 5, sir. Okay. Okay, we need to the denominator is in the form of 2 power n to 5 power m, but what we get here 77 by some 2 into 3 into 7 into 5. All right, 7 into 5. So we are getting like this. That's why it is not in the form of denominator is not in the form of 2 power n into 5 power m. It is not in the form of 2 power n into 5 power m. Therefore, it is non-terminating recurring. Non-terminating decimal. Non-terminating decimal. Okay. All right. So I hope you understand the concept what we are dealing with. So first we just started with the decimal expansion. First, whatever the question they given, you just convert it into the form of 2 power n to 5 power m, the denominator. Okay. If it is in the form of that like this, then you can confirm as it is a terminating decimal. If it is not in the form, so you can write it as non-terminating decimal. Okay. I hope you enjoyed the session. So where we started, we just revise all the topics, guys. Why? Because this concept is really important about where we started. Yeah, this terminology, terminating, non-terminating, recurring, non-recurring, these words are important. Okay, and this concept is really important in this exercise. Okay, what are the terms we get in rational number and irrational number? For rational numbers, terminating decimal, non-terminating, recurring. Just now we solved the first exercise. We solved this one. For irrational number, we got this one. Okay. Okay, so I just end up here, guys. Thanks for being here. So try to revise all the topics once again after the class, and try to revise all the concept and understand what is terminating, non-terminating, everything. Okay. Yeah. So bye bye everyone. Let's meet on the next session. Have a good day. Bye bye.
E-Days.